So this is titration 2, and all of the titrations are linked to each other. So in our first titration, we titrated sodium carbonate against HCl. And we're going to use the concentration of HCl that you found out in titration 1 to find out the concentration of NaOH in this titration. So we call this a standardized solution because it's an accurately known concentration found by titration. So again, in a question, we go attic and basement for our sheet so that when we get to redox, you will not be confused and you'll know what's where. We're always looking for a VMN, possible extra info. Is there any other number in the question that we need to do with? We've said that this is the weird number or the burette number. This one is the perfect number or the pipette number. And you have to work out what is what. So in this case today, this was the NaOH and this was the HCl. So we go through our pieces of blurb or the information you had for your questions. This one was 24.9 centimeters cubed. Our answer for our titration 1 should have been this. Our ratio now is a 1:1. This is our question mark. We're trying to find out the concentration of NaOH, and it was 25.0 centimeters cubed. So we are using the funky W to do your maths. You're going to do this in your extra pages. We have said this is the way in, this part here, and when we are done, when we get to over here, we will have worked out our question mark. So the first thing that we always do is, if you wish, you can divide it in half. So this left side today is going to be the attic side, and this right side is the basement side. It doesn't always follow that way. Sometimes the left can be basement and vice versa. But what we do is we use our way in, so 0.244 big M, and I always ask you to expand it, so that's 0.244 moles in 1,000 centimeters cubed. We know that down at the bottom, we're going to put this into moles per centimeter cubed. So to do that, it means the first piece of maths I'm doing is a division. So when I do that, I get 1.244 by 10 to the minus 4 moles. Whatever your calculator gives is absolutely fine. We're heading up to this point now on the flat line. This point in the flat line all has to do with end point information. What are the moles at the end point? So I want to have moles in 24.9 centimeters cubed when I'm done. So to do that, I need to multiply moles per centimeter cubed by 24.9. And when I do that, I'm going to get 3.098 by 10 to the minus 3. The ratio is 1:1. And as you can see, I have used on the left-hand side all of those three numbers. So we're now flipping to the right. So I've just used my ratio as 1. This now means 3.098 moles in 25 centimeters cubed. And that's again at our end point. I need to get to this point, and we know when we are going down is a division, and we know that we're going to moles per centimeter cubed. So to do that, 3.098 by 10 to the minus 3, which I didn't put in here, and that is going to be divided by 25. When I do that, I get 1.239 by 10 to the minus 4 moles. I want to get back up here to my big M value. When we go up, it's a multiplication, and go from moles per centimeter cubed to moles per litre. I multiply by 1,000, and I will get 0.1239 big M. So I've used all of these numbers, and I have found out what my question mark is. So 0.1239 big M. They will ask somewhere 239 big M. They will ask somewhere for a concentration calculation. It could be in moles per litre, it could be moles in 1 centimeter cubed, it could be moles at the end point, that you might have to convert it into grams for yourself, and you need to know how to do it. So this is the big M value. here, 0.1239 big M. We know we want to turn it into grams. Every time you have to convert something into grams, you know that there's a molar mass calculation that has to happen. So this is how I'm asking you to do your layout. So 22.99, oxygen is 16, and hydrogen is 1.008. It means if you screw up in the answer that you're going to write down here, then they'll give it you, it's called a slip. They'll take away 1 mark, as opposed to you just give them a final answer and it's wrong, that's 0 marks. So the always to 4 significant figures if we can. So that 8, we have to decide what that 8 is going to do to the 9 in front of it, and it'll push it all to 40. So 4 significant figures, away we go. Now the fast way to do this is literally just to multiply it by the molar mass. So moles by molar mass will give you grams. But I like dimensional analysis, so this is in moles. If I put moles under the line, I can cross these guys off. It's the exact same thing, it's just a more scenic route. And again, to 5 significant figures, I have now got my final answer. Okay, so it's so formulaic titration maths. Once it clicks, there honestly should be 0 problems, but it just does take practice. So give it the time.